Okay, here we are in section 5.6. This is a big and challenging section. First question is we're going to start with determining, for each function, determine the long-run behavior. What do we mean, the long-run behavior? Well, we mean if you have a function, and say you have a graph, and it goes like this, and, and then another... It goes like that. We mean as it goes off. Here, let me change this a little bit. What if the function kind of goes up and then like that? So, didn't do a very good job there. Let's see. So we're saying if this function, looks like that. Let's suppose, I don't know what the function really looks like, but suppose it looks like that. Well, that would mean long run, it means as x goes to infinity, positive infinity, way off to the right, positive infinity, to the right forever, how high, what height? Well, as x goes to infinity, does the graph level off at some height? That's what we're really asking. When we say, what is the long-run behavior? We mean in the long run, as you go to the right or the left, same thing, as you go to the right or left forever, does the graph level off at some height? So this graph would be getting closer and closer to a height of 0. It's leveling off at a height of 0. Okay, now let's, so that would be called a horizontal asymptote. Y equals 0, a graph like that. I'm not saying that's what this graph does. I'm just saying there's one thing that could happen. Here's another thing. We could have a graph level off like this. Let's see if I can do it. At a height of 1. This could be, height of 1 here. This is like 2 up here and 3, this is 0. So it could be leveling off at a height of 1. As you go, towards positive infinity or negative infinity. So the long run behavior of that graph as you go in, the long run, way off to the right, way off the, does it level off? It levels off at a horizontal asymptote. That dotted line is called a horizontal asymptote. This right here, horizontal asymptote. Y equals positive 1. That would be at a height of positive 1. That's something else that can happen. Sometimes, to the right and the left forever, a graph will level off at a height of positive 1. Now, there's another thing that can happen. There's really a lot of things that can happen, but there's a third major thing that can happen, and that is you can have a graph that just, it just kind of goes, up forever to the right, and same thing to the left, down, as you go towards positive infinity or negative infinity. This would have no horizontal asymptote. That one does not level off. It just goes up forever to the right, down forever to the left, or it could go, it could be like a U-shape, right? What do U-shapes do? They just go up forever in both directions. Or it could be like the x cube graph, which does a snake, which goes up forever in one direction, down forever in the other. They don't level off, right? y equals x squared or y equals x cubed, they have no horizontal asymptote. They don't level off in the long run as you go to the right or the left forever. They don't level off. But this graph, but graphs sometimes do. Like this graph has a horizontal asymptote at 0. It's leveling off at 0 in the long run to the right and left forever. This one's leveling off at a height of 1 as you go to the right and the left forever. So some graphs do. So that's the question they're asking us. Do these functions level off as they go to the right or the left forever? Well, it's a good question. How are we going to answer that question? Well, let me get a little fresh space and we'll try to answer that. So come back over here. So questions, this is 5.6. Question number 1. So the first one they're giving us is x squared plus 1 over x squared plus 2. I'm just going to put a y equals or f of x equals in the front. It's understood to be there. It's the function. Okay, so anyway, so what we're wondering is, as we go, so long run behavior. Long run behavior. So as x goes to infinity, does it level off? That's the question. As we go to the right forever, does it level off? And left forever, same thing. So does it level off? Well, what you could do is you could try plugging in x equals positive 100, right? Because that's way off to the right. You know, if we're wondering, what does it do? We have to go way over here and find out what it's doing on the x-axis at positive 100. Here's 0, you know. Go way over to the right and just find out what the function's doing. Well, let's see. Y equals, if I plug in positive 100, here I'm plugging in positive 100 for x on the top and positive 100 for x on the bottom. What do we get? 100 squared, 100 times 100. Remember, when you multiply 100 times 100, you just get the 2 zeros from the first 100 and then the 2 zeros from the second 100. 100 times 100 is that number, which is 10,000, plus 1 over 10,000 again, right, 100 squared, plus 2. So that's 10,001 over 10,002. You know, if you divide that on your calculator, what you get? You guys did it on my calculator. You get 0.9999 and then 0002. It's basically, it's very close. It's super close to what? Close to 1.0, right? 0.9999. That's basically 1.0. So as we go to positive infinity, go way over to the right at 100, the graph is basically at 1.0. So it looks like as we go way off to the right, the graph is leveling off at 1.0. Y equals 1.0, or 1. Y is 1. Now, is there a way we could have figured that out easier? Because that was great. That's the right answer. That is what they want. That's a horizontal asymptote. That's a horizontal asymptote, y equals 1. Meaning, the graph, I don't know what the graph's doing in the middle, whatever, blah, 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 but eventually it's leveling out at a height of 1. It's getting super, super close to this horizontal line at a height of 1. See, 0.9999 is getting really, really, really close to a height of 1. Or I think actually the graph is below 1, isn't it? So really maybe it's down here, blah, 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 whatever. But then it's getting super, super close to a height of 1. It's underneath 1. It's just barely underneath 1, but it's getting super, super close to a height of 1. So it's leveling off at a height of 1. That proves it. Now, could I have done that more quickly? Let's go back and think about a quick way to do this so we don't have to do so much work every time. What ended up determining that answer? We got 0.9999, which we said, look, that's basically 1, so it's leveling off at a height of 1. What made that happen? Did this +1 or +2, this +1 or +2 really matter? No. It was the 100 squared and the 100 squared, which made it basically 10,000 over 10,000. The +1, the +2, that's nothing, right? 10,001, 10,002, that's nothing. So in other words, all that matters is the most powerful term on the top and the most powerful term on the bottom. The other stuff is chump change. The other stuff is so small, it doesn't matter. When you're going to 100 or infinity, right? Because remember, this is long run behavior. X is going to infinity. You're going to plug in 100, 1,000, 10,000, a million, a billion, a trillion, etc. You're going way off to the right. You're wondering way off to the right. As x goes towards infinity, what happens? Well, if you're going to plug in really big numbers like 100 or 1,000 or 10,000 or a million or a billion or a trillion, here and here, all that's going to matter, I'll say only the most powerful term, only the highest power terms on the top and bottom matter. They're all that really matters, right? The other terms are so small. When we're talking about long run behavior, when you're plugging in basically infinity, really huge numbers. So just get rid of these guys. Who cares? So this just becomes x squared over x squared. And what is x squared divided by x squared? 1. There's our answer. That way you don't have to plug in the 100 and mess with the numbers, right? That's what happened when we plugged in the numbers anyway, right? The 100 squared and the 100 squared overwhelmed the little +1 and the +2. So they didn't matter. It became 10,001 over 10,002, which is 0.9999, which is basically 1. So that'll tell you the long-run behavior, the horizontal asymptote, the leveling off, how the graph levels off as x goes to infinity. Just look at the most powerful term on the top, the most powerful term on the bottom, ignore the rest of the stuff, and then reduce this fraction, right? Same thing over itself, x squared divided by x squared is 1. So the answer is y equals 1. Okay, let's try the next one. We're still on number 1, but they have a second question, and it goes like this. It's y equals, I'm sticking to my own y, x squared plus 1 over x cubed plus 2. So now, it's almost the same as the last one, except this is now x cubed. So long run behavior, meaning as x goes to the right forever, as x goes to infinity, does it level off? That's what we're asking. So as you basically plug in infinity to this thing, what's this function going to do? All that's going to matter is the most powerful term on the top and the most powerful term on the bottom, right? When you're plugging in gigantic numbers like 100 or 1,000 or a million, right? The +1 and the +2 are chump change. They're nothing. Ignore them. So it becomes y equals x squared over x cubed. Now, how do you reduce that? That's 1 over x, isn't it? Right? Well, let's just do it this way. I mean, that's true, but let's just look at it this way. What's going to happen as you plug in something like 100? Let's plug in 100 squared over 100 cubed, right? I'll do x equals positive 100. That's like infinity, kind of. What's that going to be? It's going to be 10,000 on the top, right? 2 zeros from the first 100, 2 zeros from the second 100. On the bottom, it's going to be 2 zeros from the first 100, 2 from the second, 2 from the third. So it's 1,000,000. Do you see that? It's 10,000 over 1,000,000. What if you divide 10,000 divided by 1,000,000? What are you going to get? I'm getting 0.01. In other words, it came out really small. That's close to 0. That's like 0. Why? Why? Because the bottom power is bigger, right? I should say denominator. The denominator, the bottom, the denominator power is bigger. And so it overwhelmed it, didn't it? The million came out way bigger than 10,000. When you divide by a really, really big, a number that's bigger on the bottom, that makes your fraction really small, doesn't it? Right? You ever thought about fractions that way? If I said, hey, last night I ate a half of the pizza, that's a lot of pizza. But if I say, oh, no, I ate a tenth of the pizza, that's less pizza, right? If I say, oh, I ate 100th of the pizza, that's hardly any pizza. Say, no, I ate 1/10,000th of the pizza. That's close to zero. That's almost no pizza. That's just like the smell of the pizza, isn't it? You tracking with me? When the denominator gets big, the fraction is close to zero, right? If you ate 1/10,000th of the pizza, you basically ate no pizza. That's just a crumb. Or maybe just the smell. That's always my little silly saying. All right. So it's close to zero. So if the bottom has a bigger power, then the number, when you plug in, you go into infinity, you just plug in like 100 or 1,000 or a million, you plug that in, the bottom is going to be way bigger. It's going to overwhelm, and the bottom is bigger. That means you're close to zero. It's like they're having a tug of war. I heard a colleague describe it that way one time. The numerator is trying to pull the function up to infinity, and the denominator is trying to flatten it to zero. Who's going to win the tug of war? The bottom is stronger on this one. So that one wins the tug of war. So this answer would be y equals 0 as the horizontal asymptote, because the answer comes out close to 0. The bottom wins the tug of war. All right, one more. So the last one is they go y equals x cubed plus 1 over x squared plus 2. Now, again, the question is long run behavior. So meaning as x goes to infinity. Okay, so as x goes to infinity, does it level off? Is there a horizontal asymptote? Well, you know the deal, right? We're going to plug in like 100. Let's plug in x is positive 100. So what will y equal? 100 cubed plus 1 over 100 squared plus 2. Again, these guys are irrelevant. 100 cubed is 2 zeros from the first 100, 2 zeros from the second, 2 zeros from the third. That's that million again. Over 100 squared, 2 zeros from the first 100, 2 from the second. That's 10,000. If you divide that on your calculator, we don't need a calculator. We can just cancel zeros. Cancel, 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 cancel. What are you left with? 100 on the top. It's 100. In other words, it's big. It's going towards positive infinity. I know it's only 100, but it's because we only plugged in 100. If you went further to the right and you plugged in something like 1,000, a million, a billion, a trillion, then you would get even bigger numbers. So basically, this function is headed towards infinity. This is the kind of graph. As we go right, this function just goes up, 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 and away. It does not level off. It does not level off. There is no horizontal asymptote. It doesn't level off. Why? Remember the tug of war? Who's bigger, the numerator or the denominator? See how the numerator, let me come down here. The numerator is bigger power than the denominator. So the numerator wants to pull the function up to infinity. The denominator is trying to flatten it to 0, right? Because dividing by big numbers makes you small, but big numbers on the top make a fraction bigger and bigger and bigger. So the numerator wins. He's more powerful, higher power. And so that's why the number on the top ends up bigger and the whole fraction ends up big. It's going towards infinity. It's going up, 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 and away like Superman there. So it does not level off. There's no horizontal asymptote on that one. Okay, so let me give you a nice summary. We've seen the theory, why, what's going on. Here's how you discern horizontal. I'll give you some rules now. I wanted to give you the logic first off. Now for the rules. Horizontal asymptotes. What's the rules with horizontal asymptotes? Number one, if the denominator, we'll start with the numerator. If the numerator, I'll let n equal highest power in the numerator, and d equal the highest power in the denominator. So if the numerator power is higher than the denominator power, right, numerator higher, then that means it does not level off. It does not level off. If the numerator is bigger power, right, it does not level off. There's no horizontal asymptote. No horizontal asymptote. It heads to positive or negative infinity, right? It's a graph, if I was to draw, let me draw for you over here, a graph, what it might look like. It's the kind of graph that either goes up forever or maybe it'll go down forever, but it doesn't level off. Let's go to case 2. Case 2, the numerator power equals the denominator power. Powers are tied. What's that going to do? That's going to be the horizontal asymptote is y equals a over b, where a and b are the number in front, numbers, let's say numbers, a here, let's do a and b, are the numbers in front of the highest power terms. Numbers in front, called the coefficients. Coefficients, numbers in front of highest power terms. Numbers in front of the highest power term. Here, let me separate this. This was that other one. Numbers in front of the highest power terms. Make sure that you understand this graph goes with that one. Okay. So, in fact, maybe what I should do is just move that out of here. It's just kind of confusing, huh? Let's move it out of here. Of highest power terms. Let me separate this. So this one, let me put this one up here again. This one is a graph. So case number 1 is a graph that goes up forever to the right or down forever to the left. All right, so you just take the numbers in front. So this would be a case where the graph does level off at a certain height, like maybe, let me give you an example. So y equals 5 minus x plus 3x squared over 4x minus 2, 4x minus 2x squared plus 7. So what would be the case here? See the power on the top. There's the most powerful term on the top. There's the most powerful term on the bottom. They're tied. Numerator equals, right? They're both 2 power. 2 equals 2. They're both 2 power. So the horizontal asymptote would be y equals. So all that matters is you grab the 3 and the minus 2. Because you're really going to have 3x squared over minus 2x squared, right? They're all that matter. They're the most powerful terms. As you're going x towards infinity, you're plugging in infinity. You're going to the right forever, long-term behavior. As you do that, all that's going to matter is the most powerful term on the top and the most powerful term on the bottom. They'll overwhelm all the small guys, and then these x squareds are the same, so they cancel. 3 over negative 2. The horizontal asymptote would be y equals negative 3/2. So actually, that would, let me show you what that'd be negative. That I hope you know that number is negative 1.5. 3 divided by 2. Doesn't matter where you put that negative. I put it in the front, it was on the bottom, whatever. So the graph would look something like this. At negative 1.5, there'd be a horizontal asymptote. So maybe the graph's, up here, whatever, doing whatever, but it will come down and maybe down here, whatever, but then it'll eventually level off at negative 1.5. That's what that means. Horizontal asymptote at negative 1.5. So that's case 2. And then now let's go finally to case 3. Case 3 is where the numerator is lower than the denominator. So in this case, numerator is a lower power. So in that case, remember it's a tug of war. So who's going to win? The denominator. And so it'll be horizontal asymptote y equals 0. So y equals 0 here. Horizontal asymptote y equals a over b there. And no horizontal asymptote. There are 3 cases. Let me give you an example of this one. This would be something like y equals 5 minus 12x over 4x squared plus 6x. So notice who's got a more, so this is the most powerful term in the top, this is the most powerful term in the bottom. Who's bigger? Who's stronger in the tug of war? The denominator. Denominator is bigger, stronger, right? The numerator is lower. So the bottom will win the tug of war. The number on the bottom of the fraction will be 0, and it'll basically head to 0. Remember back here when we reasoned, that if the bottom of a fraction gets really big, like 1 over 10,000, that's basically 1/10,000th of the pie, that's basically, or of pizza, that's basically no pizza. So if the bottom wins the tug of war, he flattens the graph down to 0. So that's the third case. So it's all about the power of the numerator and denominator and who's bigger. Who's bigger? So that's how we answer that question. Okay, that was a long answer, but that should help us with the rest of the questions. Let's go back now. We'll go to number 2, and we'll be able to go faster now that we know all that theory. So there's number 1. Now let's finish number 2 right here. So we can do number 2 easily enough. Get rid of all this stuff right here. So number 2, they want the horizontal asymptote. So that means you just take the most powerful term on the top, this guy. Who's the most powerful term on the bottom? That guy. How do those powers compare? Numerator equals denominator. So the long-term behavior, as x heads to the right forever, y, the horizontal asymptote, will be y equals minus 5x cubed over 2x cubed. They're even, so they cancel. Minus 5/2. There's the answer. Minus 5/2, right? It'll level out at, that's negative 2.5 if you want a decimal, but they want a fraction answer. I'm just letting you know. That means this graph, if we were to graph it, and we will be graphing in a few minutes here, this graph would level out at negative 2.5, as you go way off to the right or left forever. That would be the horizontal asymptote, the leveling off. So see how easy it is then? We just grab the most powerful term in the top, most powerful term in the bottom. That's all that matters. If they're tied, you get y equals minus 5 over 2. All right, now number 3. So let f of x equals that function, and now they want us to find 10 million things about that function. Okay, let's go through the stuff. So first off, they want us to find the Y-intercept. Now, we've talked about these kinds of things, but I think we better get a little fresh space on this. And let me go back here. Get some better space. So on number 3, let me move this over here. All right, so on number 3 here, they're giving me f of x equals 3x squared minus 4x minus 4 over 3x squared minus 13x plus 12. And they want us to find a bunch of stuff. So first off, let's find the y-intercept. Now, remember how we find y-intercepts? It always means opposite letter 0. Plug in x equals 0. Remember, for a y-intercept, x equals 0. For an x-intercept, y equals 0. It always means the opposite letter is 0. That's an intercept point. So, okay. So, right, because on a graph, if you have some kind of graph, whatever, it goes through a y-intercept up there, that means it's over 0 up some number, doesn't it? It's x is 0 at a y-intercept point. At a y-intercept point, the x value is 0. That's why we plug in x equals 0. That's what it means to be a y-intercept point on a graph. Okay, so plug in x equals 0. So take this equation. This is y equals, I'm just going to make this y. Remember, function values are y values. Plug in 0 for x. So that'll be 3 times 0 squared minus 4 times 0 minus 4 over 3 times 0 squared minus 13 times 0 plus 12. Gone, 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 gone. Right? What are we left with? Minus 4/12. Reduce that fraction. Divide top and bottom by 4. Minus 1/3. So y equals minus 1/3. So the actual y-intercept point then is over 0, down 1/3. Remember, it has an x equals 0 along with that y value. So x equals 0, y equals minus 1/3. There's the y-intercept point. Okay, now question B. So we got that one. Question B. They want us to find the X-intercepts. So how do we find X-intercepts? Same thing. Remember the deal. Opposite letter, right? So we're going to take this and we're going to plug in y is 0. Now where's y? What's the left side, right? The function is the y. So this equation becomes 0 equals 3x squared minus 4x minus 4 over 3x squared minus 13x plus 12. Okay, so now how do I do that? How do you solve 0 equals that? How does a fraction, the question before us, is how do you have 0 equals like number over number? How does a fraction equal 0? I hope you know. The only way a fraction can equal 0 is when the numerator, the top, equals 0. The denominator has nothing to do with it. The denominator can't do it. Why not? If you have any number over 0, that's infinity. Remember, if the bottom of a fraction goes to 0, that's infinity. Because, take any number you want, like 3 over 0. 0 goes into 3 an infinite number of times, doesn't it? Remember, fractions are dividing. 10 divided by 2 is 5 because 2 goes into 10 5 times. So 0 goes into 3 infinite. So the bottom of the fraction being 0 doesn't make the fraction equal 0. It makes it infinity. the top of a fraction being 0. If I say last night I ate 0/3 of the pie, that is a weird way to say you ate no pie, right? So 0 in the top makes the fraction 0. So whenever they say we have a fraction equal to 0, you want to right away know, oh, that means I'm going to take the top, the numerator, bring it over here and say numerator, you must equal 0. That's the only way that fraction's becoming 0, is if that numerator is 0. Okay, so I'm going to get rid of some of this stuff, get out of our way. So now I've got to solve that equation. Now there's two ways to do it. You can factor or you can use the quad. So I know most people prefer the quad. It's good if you really want to grow in your ability to factor. If you're going to go higher in math, like pre-calc and calc, you really need to learn to factor. You're not going to make it. I mean, and not just really, you must. You will not make it if you can't factor. So let me show you factoring, but I'll also show the quad because I know that's easier for most people. But I encourage you to keep trying factoring, keep practicing it. You'll get better and better. Here we go. So we're looking for two numbers that multiply to be 3x squared. What is that? 3x and x. Those will multiply to be 3x squared. Right? The front times the front. Now, let's jump to the back. We also need two numbers in the back that multiply to be 4. What multiplies to be 4? Well, it could be 4 times 1 or 2 times 2. How do you know? Well, you don't. You just try it out. Let's put 4 and 1. Now, it turns out that's not right. How do you know? Well, let me just put in all plus signs at first. I know it's not all plus. There's obviously minus signs. But I'm just going to check it. So I'm just going to take 3x, go boom, boom. What do I get? 3x squared plus 3x. Take 4, go boom, boom, plus 4x plus 4. Any way that 3x and 4x can make the middle term a minus 4x, even if I change the signs, no way. 3 and 4 make 7, or even if you subtract them, maybe it'll make 1 or negative 1 or something. It's never going to make the middle. Remember, you've got to, the two middle ones have to make the middle one. And there's no way it's going to work. Well, okay, try switching these guys up. What if you put the 4 here and the 1 there? Try it again. It's just a matter of guess and check. It really is. You just got to get faster and faster at multiplying these things out by practice. So what's that? 3x squared plus 3x, boom, boom, plus 4x plus 4. Can the middle two? No, again, the middle two, no way. So it's not going to work. They make 7, or if you subtract them somehow with negative signs, maybe 1 or negative 1. No way. So, okay, it's not 4 and 1. What else can we do? Remember, because you got to multiply to be 4 here, it can be 2 and 2, can't it? 2 times 2 makes 4. So now it's probably that. I'm just going to leave plus signs for a minute and check out. I'll change the signs as needed. 3x squared plus 6x, right? 3 times 2. And then this guy goes to both. Plus 2x plus 4. Now, it's not the right signs, but can I fix the signs there in the middle to make negative 4? Yeah. If you make that 6 negative, right? Negative 6 plus 2 will make negative 4. So what's that mean? It's always, let me give you a little rule here. It always goes to the opposite sign right there. That means that guy is negative, because that negative 2 multiplies that 3 to make that negative 6. And that does multiply these guys to make negative 4 at the back, right? Positive 2 times negative 2 does make our negative 4. It's good. It's right. That's the right factorization. I proved it by checking. So now I'm going to erase my check here. I know it's right because I multiplied it out. That is the correct factoring. And then if you factor, now remember it's equal to 0. These guys are equal to 0. So what do you do then? Remember, you just set each one equal to 0 separately. Why? Because if two things are multiplying, parentheses are multiplying to equal 0. If I said, hey, I'm thinking of two numbers and they multiply, right, parentheses, they're multiplying to equal 0. I'm thinking of two numbers and they're multiplying to equal 0. What does that mean? You know what that means. Either the first one could be 0 because 0 times anything is 0, or the second one could be 0, right? Anything that multiplies with a 0 equals 0. Well, that's what this little thing is saying. Something times something is equaling 0. So the first one could be 0 or the second one could be 0. Either way, it'll equal 0. And you know how to finish this. Just jump that 2 to the other side, becomes a negative 2, changes sign. Divide by the 3. Same thing, jump that -2 to the other side, becomes a +2. So there's the two answers, -2/3 and +2. Now you could get the same thing by doing the quadratic formula. I'll do it real quick. I'll say, or, let me come over here. I'll say, or -b, if you don't like all that factoring, but I encourage you to learn to factor. -b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula will solve any x squared equation. This is a, b is the -4, c is also -4. So it becomes a -b, -4, right? Because b itself is -4. Plus or minus the square root of b squared, -4 squared minus 4 times a, which is 3, times c, which is -4, all over 2a, 2 times 3. Okay, so what does that equal? Well, the two negatives here become positive, so it's regular 4, +4, plus or minus the square root. -4 squared is 16. Now, watch your negatives here. Negative times positive times negative. That's two negatives. It's going to be positive. Multiply those in your calculator, you'll get 48 all over 6. So bring that up here. That's 4 plus or minus, what's that going to be? 60, square root of 64 all over 6. That's 4 plus, and the square root of 64 is 8, right? Square root of 64 is 8. So that's 4 plus 8 over 6, or 4 minus 8 over 6. That's 12 over 6, 2. See how we got that answer? Or, what's this one going to be? -4/6. Reduce that fraction, divide by 2 top and bottom. -2/3. That is indeed the other answer. So you can get the same two answers by factoring or by the quadratic formula. Those are the X-intercepts. How do we write the final answer? So the final answer, I'll put it over here, is 2, 0 and -2/3, 0. Because again, you got to go, these x values go with a y value of 0 because it came from y equals 0. So there's the x-intercepts. It's a lot of work. Let's go to part C. So part C now, they want us, or actually part 3. So we're still on question number 3, which had the function y equals 3x squared minus 4x minus 4 over 3x squared minus 13x plus 12. And now on part 3 of it, they want us to find the vertical asymptotes. The vertical asymptotes. Okay, so how do we find vertical asymptotes? Well, vertical asymptotes, let me explain. Vertical asymptotes. What is a vertical asymptote on a graph? Let's show it. A vertical asymptote would be a place where the graph goes up or down, right? Goes up to positive infinity or down to negative infinity. That's what happens at a vertical asymptote. Now, what makes a graph, especially a fraction, go to positive infinity or negative infinity? Remember what makes it happen? It's when you have a number over 0. Again, let's think about how fractions work. If I take 10 divided by 2, we all know the answer is 5, and that's because the bottom goes into the top, 2 goes into 10, 5 times. So what would be 10 over 0? How many times does 0 go into 10? It goes in there forever, doesn't it? Right? And if you make that -10, then, it's negative infinity, because if you have a negative sign, it's negative, but it's still infinity. 0 goes into 10 or -10 forever. So the way you get a vertical asymptote is when the denominator equals 0. That's what makes a vertical asymptote. So whenever they ask us for a vertical asymptote, we're taking this denominator And we're saying, okay, how can that equal 0? How can 3x squared minus 13x plus 12 equal 0? Well, again, I'm going to show you two ways. You can factor it, or you can use the quad. So I hope you're getting better at factoring. So we're looking at two numbers that multiply to be 3x squared. That'd be 3x and x. And that multiply to be 12. Now, what multiplies to be 12? 3 times 4, 2 times 6. Yeah, there's a lot of options. How do we know what to do? Well, if we tried to do 3 times 4 like that, no way. Why? Because you're going to never have two numbers in the same parenthesis with anything in common. You're never going to have two numbers in the same parenthesis that have anything in common. Why not? Because then you could take out that 3 and it would be just 3 times x plus 1, right? If that was a plus in the middle there, right? You could, if they have a 3 in common, you could just take it out. Okay, so why is that the end of the world? That can't be, because from the beginning there was no 3 in common, right? 3 didn't go into 3, 13, and 12 doesn't go into 13. Right? So there's not really a 3 in common in the beginning. How could there be a 3 in common later? Can't be, right? So you're never going to have two numbers. You couldn't put a 6 here either, because again, you would take out a 3, and that would be 3 times x plus 2. That would have a 3 in common, and we never had a 3 in common from the beginning because 3 never went into 13, so there can't really be a 3 in common later. So you're never going to have two numbers in the same parenthesis that have anything in common. Let that speed you up in your factoring. So the 4 has to go there and the 3 there. That's a possibility, right? Because now there's nothing in common, right? 3 and 4 have nothing in common. X and 3 have nothing in common. So that might be it. Let's just make them both plus and check it. Boom, boom. 3x squared plus 9x, boom, boom, plus 4x plus 12. First to both, second to both. Can the middle two make minus 13? Yeah. What signs do they need? Both negative, huh? So let's go back and make both these guys negative. That'll make this negative, both these guys negative, negative 9, negative 4, make negative 13. And two negatives will multiply to be plus 12. That's it. So that's the factorization. And that works. We checked it. And so now what do you do from here? Remember, you set each one equal to 0, because if two things multiply to be 0, either one could be 0 to make that happen. Jump that over. 4 divided by 3, 4/3. Jump that over. Positive 3. So that works. Or you could do the quad. I'll come over here and do the quad again. So let me go back to do the quad. I'll say or, if you don't like the factoring, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we go back and we grab them. So this is the a is 3, the b is negative 13, the c is 12. So negative 13, negative b, plus or minus the square root of b squared, minus 4 times a, which is 3, times c, which is 12, all over 2 times a. Okay, let's simplify that. That's going to be 13 plus or minus the square root of 169, 13 squared in your calculator, minus 4 times 3 is 12, times 12, 144 over 2 times 3 is 6. So that's 13 plus or minus the square root of 25 all over 6. We're getting close. That's 13 plus or minus 5, right? Because the root of 25 is just 5. So break that up. That's 13 plus 5 over 6, or 13 minus 5 over 6. That's 18 over 6. 3, like we got there. 13 minus 5 is what? 8 over 6. Reduce it. Divide top and bottom by 2. And that's 4/3. That's our other answer. Those are the two vertical asymptotes, 3 and 4/3. That means on the graph at over 3, there's going to be a vertical asymptote. And at 4/3, which is 1 1/3, so it'd be just past 1, there's going to be another vertical asymptote where the graph goes up or maybe down to infinity at those places. Because they make the denominator 0, right? When you make the denominator 0, you get a vertical asymptote because the graph goes up to infinity when you make the denominator 0. So there's that part. And last is a long question. Number 3, again, last part. Y equals 3x squared minus 4x minus 4 over 3x squared minus 13x plus 12. So now the last part, part 4, they want the horizontal asymptotes. How do we find horizontal asymptotes? We went through a whole discussion about that earlier, remember? Back here, there it is. Horizontal asymptotes, it's all about the power of the numerator and denominator. If the numerator is higher, then, you know, there's no horizontal asymptote. If they're equal, then it's a over b. And if the numerator is lower, then it's y equals 0. Right? Because it's a tug-of-war between the numerator and the denominator. Horizontal asymptotes are all about what the graph does way off to the right or way off to the left. Long-term behavior. So, what's the most powerful term on the top, most powerful term on the bottom? It's y equals 3x squared over 3x squared. Just cancel. It's going to be 1. So it's y equals 1. That's the horizontal asymptote, which means on the graph, at a height of 1, that graph is going to eventually level off at a height of 1, off to the right and off to the left forever, the long-term behavior. It's just tug-of-war, most powerful term on the top and the bottom, long-term behavior. There we go. That was a long question. Let's go to number 4. So this is number 4 right here. What they're doing is they're giving us some graphs, and they're saying, here's a function, here's y equals that function, and they want us to put the horizontal asymptote actually on the graph. So you'll use the graph making tool, you'll make a straight line, and you'll put it right on the graph. Can you see the horizontal asymptote? Can you see the flat line that they're leveling off at? It's right here at 0. That's y equals 0. That's a height. That's hitting the what? The y-axis. This is the x-axis. It's hitting the y-axis right here at a height of 0, isn't it? It's y equals 0. That's the horizontal asymptote. And let's come over here. And now they want us to do the vertical by just looking at the picture. Can you tell the vertical dotted line that they're both approaching? These asymptote lines are lines of approach. Lines the graph gets closer to forever. Well, it's right here, isn't it? There it is. That's hitting the what? X-axis, not the y. It hits the x-axis right here. X equals -1. There's the line of approach. And here is question number 5. And it's the same kind of thing here. Question number 5. That was kind of a funny looking 5 there. Question number 5. Same thing, they're giving me this thing, and they want me to find the horizontal asymptote. Well, can you tell just by looking at the graph? It's right here. It hits right there on the y-axis at -2, doesn't it? And over here, the vertical. Maybe I should do it like that. It's a little better looking, huh? It hits the x-axis, not the y. It hits the x-axis at -3. We just pop that on there. So same function, just giving the horizontal and vertical asymptotes on that. Okay. Number 6. Draw a graph of that function by first placing the horizontal and vertical asymptotes and then plotting an additional point on the graph. You can see here's the answer. It's already down there at the bottom. So how do we get all that if we didn't already have that answer? You know, how would we figure this out? So we have y equals 2x minus 3 over x minus 1. And they want, first off, they want us to figure out the horizontal. Let's start with that. So how do we find horizontal asymptotes? Remember, that's the tug-of-war. Numerator versus denominator. Tug-of-war. Let's take the most powerful term in the top. That'd be the 2x. And the most powerful term in the bottom, just the x. And then what is that? These x's cancel, y equals 2. So the horizontal asymptote is right here. Oops, let me draw that a little better. At y equals 2. It hits the y-axis, right? The y-axis at 2. Now for the vertical. How do we do vertical asymptotes? Well, that's all about what makes a vertical dotted line. Remember on a graph, a vertical dotted line, a graph goes up or down to positive infinity or negative infinity. What makes a fraction go up to positive infinity or down to negative infinity? It's when you have a number over 0, right? When the denominator is 0, 0 goes into anything an infinite number of times. That's what makes a fraction infinity or negative infinity, if it's a negative number, is the bottom being 0. So we just say, okay, what's going to make the denominator equal to 0? You grab that denominator, x minus 1, and you say, then you solve it. Move that 1 over, x is positive 1. So right here, at hitting the x-axis at positive 1, must be the vertical asymptote. Now, when you use the little graph making tool, they want you to first start with this dot. They want you to click on the dot, which is the center of the crosshairs. It's where the vertical and horizontal asymptote lines meet. The center of the crosshairs. They want you to click there. Okay, and then after you click there, it'll put the two asymptote lines, the center of the crosshairs right there, and then as you move your mouse off of that point, it'll start to make two branches of the function. And you just need to click one more dot. That's what they mean by an additional point. So we just need to find one more point. So let's come down here and find one more point. One point. 1 point on the graph. How do we find 1 point on the graph? Well, I think you plug in anything you want. I'm going to plug in what's the easiest number of them all? 0, right? Let's plug in x equals 0 just to make life easy. Let's take that equation. Y equals 2x minus 3 over x minus 1. Let's take that 0 and put it in. And so what do we get? That's just going to be minus 3 over minus 1, right? The zeros, this part just goes away. And that's plus 3, isn't it? So that means 0 plus 3, x 0, y plus 3 is a point on the graph. Because I plugged in x equals 0 and I got y equals plus 3. So that's got to be a point on the graph, right? That makes the equation true. So over 0, up 3, right there is a point on the graph. So all you have to do is click that point. So once you start with clicking the center of the crosshairs, it'll put the crosshairs there. Then it wants one other point. You click there. So that basically means one of the branches is, and it'll draw it for you automatically. It means one of the branches is over here. The other one will be symmetrically the same, diagonal. So it'll go diagonal right through there. Boom. It'll be right there. But you don't have to worry about that. The graph making tool will do it automatically. All you have to find is the 0, 3. Click the center of the crosshairs and then click the 0, 3. Boom, it'll make your graph. You can see it's true. Boom right there. Boom right there. There's the center of the crosshairs. And we've got it. There's the graph on that one. Okay, let's go on with number 7. Number 7, write an equation for a rational function. Vertical asymptotes, x equals 1 and 2. X-intercepts, 6 and 5. Y-intercepts, 6. You can see the answers already there. Okay. So how do we do this? Well, remember that vertical asymptote. So first off, it's going to be y equals a and then a fraction. And basically, we're going to have x, like that. And what goes, the vertical asymptotes, remember, denominator equal to 0. So these are going to go in the denominator. So it's going to be x plus 1, because remember, it's always opposite. And, oh, whoops, that should be minus 1, shouldn't it? That's the opposite. X minus 1 and x minus 2, because there's always opposite in when you put a number next to x in the parentheses. Oops. Denominator, so remember, vertical asymptotes. Let's go back and make sure this is making sense. Where did I do it? Right here. Remember, well, I don't know, I put it somewhere else, I guess. There it is. Vertical asymptotes are what makes the denominator 0, right? That's a vertical asymptote. I'm going too far here. So vertical asymptotes, because if you have a number over 0, that's what equals infinity. When y equals a number over 0, when 0 is in the bottom of a fraction, that's what makes that fraction infinity, which makes a vertical asymptote there. So if x equals 1 and x equals 2 are vertical asymptotes, they must make the denominator 0. See, if I plug in x equals 1, it'll make that part 0. Or if I plug in x equals 2, it'll make that part 0. And so that's why so we must have, x equals 1 or x equals 2 plugged in. We must have x minus 1 and x minus 2 in the denominator of this rational function, this fraction. Rational just means ratio, fraction. This rational function, because we know that when x is 1 or x is 2, those are vertical asymptotes, so those must make the denominator 0. Because when you make the bottom 0, the fraction goes to infinity. Okay, so we have those, and it's always opposite. Whenever a number's next to x in parentheses, it's always opposite. Okay, now what about the numerators? Well, X-Intercepts. Remember what an X-Intercept is? Remember what we said? X-Intercept means y equals 0, and Y-Intercept means x equals 0, right? Intercept points. So I think about a graph, blah, 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 like this. Okay, here's a Y-Intercept. Here's an X-intercept. Again, think about what this point means. This is over 0 up some number. His x value is 0. This Y-intercept has an x value 0. And this point must be over some number up 0. His y value is 0 at an X-intercept. So at an intercept point, the opposite letter is 0. So at an X-intercept, y is 0. At a Y-intercept, x is 0. That's just what it means to be a point on the grid line. The opposite letter is 0. If you're a Y-intercept, your x is 0. If you're an X-intercept, your y is 0. Okay, so what? So that means, let me get rid of this. That means that these points, x equals 6 and x equals 5, they make y 0. They make y 0. Well, how do you make y, the whole function, y, over here, right? This is y. Well, how do you make y 0? Let me go back to the way it was. This is y equal. We're saying y is 0. How do you make, and notice this is a fraction. Y equals a times number over number. If I said, hey, y is 0, it's a times number over number. How can all of this equal 0? Only if the top is 0. Remember, the only way you can make a fraction 0 is by making the top 0. Right? That's the, well, or of course a could be 0, but that's not going to be it, because we'll see why in a little bit. So if you make a 0, then just the whole thing's 0. It's just 0 equals 0. It's not even a function. It couldn't have those vertical asymptotes. It couldn't do anything. So we can't make a 0. Well, then what can we do? You can make the top 0. Right? Not the bottom. If the bottom is 0, we know that just makes infinity. Those are vertical asymptotes. But the way to make the whole fraction equal 0 is to make the top 0. So basically, they're telling us at an X-intercept, which means y is 0, which means the top equals 0. So this must be x minus 6 and x minus 5 in the top. Because x equals 6 and x equals 5, see if you plug in 6 there or 5 there for x, it'll make the top 0, which will make the whole fraction 0, which will make y 0, which is an X-intercept where y is 0. So Is that making sense there? So what we're seeing then, what they want you to understand is that at vertical asymptotes, the denominator is 0, because that's what makes it infinity. At x-intercepts, y is 0, and what makes y 0 is the top being 0. So you put the opposite and the opposite, because you always put the opposite of the x number next to x. So opposite of positive 6 and positive 5 is minus 6 and minus 5. That way, if you plugged in 6 or you plugged in 5 for x in the top, you would make the top 0. You make the whole fraction 0. Y would be 0, which means it's an x-intercept, okay? So now, last thing, how do we find A? Well, that's going to come down here from the y-intercept. So to find A, plug in what? X is 0, y is 6, right? X is 0, y is 6. So y is 6, and x is 0. 0 minus 6, 0 minus 5, over 0 minus 1 times 0 minus 2. So here, I'll change the color. A times a negative 6 times negative 5 over negative 1 times negative 2. And that comes out to be, what's that, 30. 6 times 5 is 30 over 2. And that's A times 15. 30 divided by 2 is 15. Last step to solve for A. Divide by 15. A must be 6 divided by 15 in your calculator. 0.4. So A is 0.4. So we have our answer now. So you grab this guy, bring it down here. Y equals A times x minus 6, x minus 5 on the top, because those are the x-intercepts, makes the top 0, makes y 0. And the bottom is x minus 1, x minus 2, because those are the vertical asymptotes, makes the bottom 0, makes the y go to infinity. And now we know what A is. A is 0.4. So there we go. All right, let's try number 8. This will be similar, a little different though. Actually, maybe a little easier. All right, so again, write in the equation vertical asymptotes 2 and negative 3. Remember, that means denominator equal to 0, because when you have a number over 0, that's when a fraction goes to infinity, when the denominator is 0. So we're going to go y equals A, and the bottom is going to be x minus 2 and x plus 3, because remember, those are opposites. So that way, if we plugged in positive 2 or we plugged in negative 3, I'd make the bottom 0, make the bottom of a fraction 0, the thing goes to infinity. That's a vertical asymptote, okay? Now, what about the top? Well, x-intercepts, remember, that's what makes the top equal to 0, because an x-intercept is where y is 0, and you make y 0, the whole function 0, by making the top 0. So that's going to be x plus 6 and x minus 1, again, opposite, opposite, so that if we plugged in negative 6 or if we plugged in positive 1, we'd make the top 0, which makes the whole fraction 0, which makes y 0, which is an x-intercept, where y is 0. All right. You've got it. Now what we got left to do is find A. So how do we find A? Well, this time they're not on the last problem. We found A because they give us the y-intercept was 6. That means x is 0, y is 6 go together, right? Because a y-intercept is always x 0. So 0, 6. So I plugged in 0, 6, right? I plugged in 6 for y and 0 for x everywhere, and found it. Well, this time, instead of doing that, they're giving me a horizontal asymptote. Now, remember what a horizontal asymptote is? Horizontal asymptote is going to be what happens as x goes to infinity, right? It's long-term behavior. Like way off to the right, it's the level that the function levels out at. Well, how do we know what that is? Well, if I was to multiply out this function right now, just leave the a here. If I was to multiply this top out, I'd get x squared minus 1x plus 6x minus 6 the bottom. You know, I'd get boom, boom, x squared plus 3x, boom, boom, minus 2x minus 6. And if I thought about in the behaviors, x goes to infinity. Remember, all that matters is the most powerful term in the top and the bottom. If x goes to infinity, because I'm trying to find the horizontal asymptote, the long-term behavior, what does the function do, you know, way off to the right? So all that matters is the most powerful term, top and bottom. So that's just x squared over x squared. And what is that? That's just a, because that's a times 1. These just cancel. Let's just get rid of it. It's just a. So a is the horizontal asymptote, you see? So, and what is that? They said it's 7. So plug that in. So a must be 7. So then our answer, we got our function now. It's this right here, and you put the 7 in the front. That's why they got that answer, because the a must be 7. So the horizontal asymptote just tells us that a number right in the front, because everything else, the x squared is the most powerful term top and bottom. As x goes to infinity, they're all that matter. It just cancels out, so y is just a. There we go. Number 9. Now they want us to, now we're going to work backwards. We're going to go from this picture, this graph, and work backwards to the actual answer, to the function that made this picture. So how do we do this? Well, we're going to notice first off a couple things. So we're going to have y equals, remember, it's going to be, let me write the general game plan here. It's y equals a, and in the top you have x-intercepts. On the bottom you have vertical asymptotes, right? That's what we did in the last couple of problems. So, okay, so then this is y equals a, and again the top is x-intercept. So what's x-intercept? Hits the x-axis right there. That's at 3. So we're going to have x minus 3. On the bottom, we're going to have vertical asymptotes. What's that? -1 and +4. So remember opposite, so +1 is the opposite of -1. And -4, that's the opposite of +4. So we have x-intercepts on the top, because they're what make y 0. X-intercept makes y 0, makes the top 0, makes the whole fraction 0. Vertical asymptotes are on the bottom, because if you make the bottom 0, you know, at -1 or at +4, you're going to make the bottom 0, which makes the whole fraction go to infinity. So those are vertical asymptotes, right? You can see at, you know, the functions going up or down, positive or negative, infinity. At those verticals, it's at a height of 0 at the x-intercept, which means plug in 3. The top must be 0, which makes the whole fraction 0. So we got that. And now how do we find the a? Well, see what we can do. We can do just like we did back on number 7. Right here, we have the y-intercept. Over 0, down 1. That's the y-intercept. So we just plug it in. Plug in 0, -1. So 0 for y, and then the -1 for x. So what do we get? We get 0 equals a times 0 minus 3 over 0 plus 1, 0 minus 4. I plugged in 0 for x and -1 for y. Solve this equation now for a. That's going to be -3 on the top, 1 times -4 on the bottom. That's a times positive 3/4, right? Because negative over negative makes positive 3/4. Let me write that a little cleaner. Now, how do you solve that equation for a? We're trying to find out what a is. Oh, wait a minute, what am I doing? I didn't put I put in 0. Y is supposed to be -1, right? y, see, I did this backwards. Let's try this again. I'm totally messed this up. Sorry about that. So the y is -1. So the y is -1. And the x is 0. I put 0 in for both. That was crazy. All right, so we get to here. Now, how do you solve that? How do you get a alone when it's got a 3/4 next to it? You multiply by the upside down, and whatever you do to one side, you have no choice but to do the same thing to the other. So then the 4s and 3s will cancel. A's alone. 4/3 times -1 is -4/3. Divide that in your calculator. -1.33333. So you can see the answer they got right there. -1. I don't know how many 3's they make you do. And then we have the x minus 1 on the top and the x plus 1, x minus 4 on the bottom. There is our answer. So it's pretty much like the last one. Just remember, x-intercepts on the top, vertical asymptotes on the bottom. You can put that right in your card for the exam. And then you find the a by plugging in the y-intercept. X is 0, y is -1. And then solve for a by multiplying by the reciprocal, the upside down of the fraction on both sides. And you get a. And just divide it on your calculator, get a decimal. There we go. Number 10, same kind of thing. This one's going to have a little extra wrinkle, though. So, okay, so let's start off. You know the normal deal. It's going to be mostly just like the last one. Y equals a. And we're going to have the x-intercepts on the top and the vertical asymptotes on the bottom, right? Because what makes the top 0, like right there, makes the whole fraction 0. So that's going to be, change the color here. Come on, there we go. Y equals a. It's going to be x minus 1. Remember, it's opposite. So right there. Now I want you to think with me a little more carefully. I want you to remember from earlier in Chapter 5, the last exam, how we learned about the difference between bouncing and passing through. Remember that? Remember how we learned that if a curve like passes through at whatever, 3 or whatever, that it would be x minus 3 to the first power. Let me make that a little nicer. First power. But if it bounces at 3, if it goes boing and goes back up at 3, if it bounces, so if it passes through, it's a first power. If it bounces, remember that would be a second power. That would be x minus 3 to the second, like that. Second power, right? Because it's like an x squared curve. It bounces. Okay, let's keep that in mind. Now this one, what? This one passes through. This passes through. So it's just first power. So just first power, you don't even need to write a 1. It's understood to be first power. All right, now let's look at the vertical asymptotes. So we have vertical asymptotes at -3. So you know that means x plus 3. And positive 2, it's opposite, so that's x minus 2. But now, let's think about the powers on those guys. It's the same kind of thing. In fact, let me move this down here so it's more clear. I'm down here. So if you have something, that bounces, if it bounces, that's second power. Bounces at 3, that'd be x minus 3 squared. Okay, now I want you to think about this more deeply because it's the same thing. So on the top we have a first power because that just passes through, but it's the same deal for the asymptote lines. What am I talking about? Basically, see how this asymptote line here, this one right here, let's start with this one. One side the graph goes down, the other side it goes up. So for this particular asymptote line right here, one side the graph's going up, the other side it's going down. So it's going different ways on the different sides. That's just like passing through. So if you have a vertical asymptote line, let me make this a little better. So if you have a vertical asymptote line, whoops, still having trouble here. If you have a vertical asymptote line, and one side it's going up and the other side it's going down, it's just first power. This is at 3 or whatever. That'd be x minus 3 to the first power in the denominator, right? That'd be whatever, blah, blah, blah in the denominator. Well, and then if it bounces, now bounces is like, so that's going to be x plus 3 first power because of that. But look at the 2. See how it's going down on this side and also down? When they're on the same side, like if they're both going down or both going up, that's like a bounce. See how these guys are both on the same side, they're both up or both down, that's like a bounce. If the two branches on the two sides, when they're on the same, if they're both up or both down, how about that? If they're both up or both down, it's second power. So that would be, this is at 3. This would be x minus, well, it's in the denominator because it's a vertical. So it'd be whatever number over x minus 3 to the second power. So that idea of passing through and bouncing, what it is, see how this is above and this is below. They're on different sides. It's like a pass-through. This is above, this is below on the two sides of the vertical. That's just first power if they're on different sides. But on the, down here for the bounce, they're both above, right? If it bounces, they're both above or both below. These are both below. It's second power for a vertical, just like it is in the top. So this is going to be second power because at x equals 2, they're both going down. If the other one was going up instead of down, it would just be first power. So if they're both down or both up, that's second power on that term. Okay, so now we need to find A. You know how we find A? We plug in this point here, over 0 up 2. Plug in 0, 2. 0 is the x, 2 is the y. So put the 2 in for y right there, and 0 in for the x. And then what do we got? Let me change the color here so we can see it better. So 2 equals A times negative 1 over 3 times over negative 6. So that 2 negatives cancel. It's positive 1, 6. How do you get A alone? You multiply top and bottom by the upside down, 6 over 1. Or just 6 if you want. So that A equals 6 over 1 or 6 times 2, 12. Whoops, I blew that. I forgot this was squared here, didn't I? Let me go back and be a little bit more careful. Let's try again. 2 equals A times negative 1 over 3 times 4, right? Because this is negative 2 squared. So 2 equals A times negative 1/12. There we go. Now multiply the top and bottom by 12 over negative 1. 12 over negative 1. Cancel, cancel. A is alone. Negative 24. There we go. There's the answer. A is negative 24. So that's important. What we learned there. It's the pass-through bounce thing. If the branch is going different directions, like one going up, one going down, that's like a pass-through, first power. Same thing in the denominator. Any kind of number, if it goes one down, one up at a vertical asymptote, that's also first power. But both up or both down for a bounce point or for a vertical asymptote, that's second power in the denominator for a vertical asymptote. Okay, let's try that same thing. We need to practice that. Let's try this on number 11. Same kind of deal. Y equals A. You know what goes on the top? X-intercept information on the bottom. Vertical asymptote information. Okay, here we go. So what's the vertical asymptote, or what's the x-intercept? Right there at, and it's opposite, x minus 1. And that's a bounce. So that means what? Second power. Right? Second power, because it looks like it's a U shape. It's second power. All right, now what about the bottom? On the bottom, we have a vertical at -2, so that'll be x plus 2. What's the power? One's going up, one's going down. First power. It's like a pass-through. They're going different directions. That's a first power. Now, what about at x equals 2? So that'll be x minus 2, opposite. But they're both going down, so that's second power. Because it's like a bounce. They're both going in the same direction. They're both going down like a U shape. Second power. There we go. Now what we do is plug in the Y-intercept. Ooh, we don't really have the Y-intercept. Right here. They're telling us. So plug in that Y-intercept. This is the X. This is the Y. So plug in right out here. Y is -0.4. And then we have, and then plug in for X 0, because of the Y-intercept, X is 0. Don't forget those squares. So -0.4a. So this is going to be -1 squared. I'm going to change the color here. This is going to be +1 over 2 times 4, huh? So that'll be -0.4a. This is 1/8. So now multiply both sides by 8 over 1. 8 over 1 to cancel out. Gets a alone for us. A is -3.2. There it is. There's the A. There's the function. We got it. So that's good. Hopefully that's making some more sense for you. Let's look at number 12 now. Same kind of thing. Good. Another one to practice. Okay, so this one's pretty much the same thing. Y equals A. On the top go the x-intercepts. On the bottom go the vertical asymptotes. Now, the graph isn't very good on this one. Let me help with that. It's really hitting right here at 0, and then it kind of goes, goes down, and then it comes back up through 2. It's really hitting at 0 and 2. You can't tell the way this graph is. On the test, I would make sure, it was more clear. So 0 and 2. So those are the x-intercepts. So that's going to be x minus 0 and x minus 2. For the x-intercepts on the top, the vertical asymptotes, you can see those, -4. So that's, and by the way, both of these this is a pass-through for both of these. So it's first power for both those guys, right? First power, passes through. It doesn't bounce at either one of those. On the bottom, x plus 4. This goes up on one side, down on the other, so that's first power. And then at 5, so that's -5, goes up on one side, down on the other, so that's first power also, right? It's only when they're both going up or both going down, like a U shape, that you do second power. All right, so now we just need to find A. So let's plug in the, let me see, what are we going to plug in? Oh yeah, there's no Y-intercept. There's no Y-intercept. No Y-intercept. Well, the only Y-intercept is here. It's 0, 0. So the Y-intercept is at 0. It will not help to plug in because it would be 0, 0, right? The y-intercept is 0, remember, and the opposite letter 0, that's the point, 0, 0. If you plugged in 0, 0, that will not help. Why not? Let me show you. If you plugged in y is 0 and x is 0, you would just get 0 equals 0 times negative 2 over 4 times negative 5. That'd be 0 equals 0 over negative 20. That'd just be 0 equals 0. You can't, oh, I forgot the a in the front. I'll put the a in the front. But a times 0, right, this would be a times 0. That would just be 0. You can't solve for a. Do you see that? When you plug in, 0, 0 is never going to work for plugging in. Because if you do, you just make the top 0, and then 0 over negative 20 is 0, and a times 0 is 0. You can't solve for a. A vanishes because a is multiplied by 0. A times 0 is just 0. A vanishes, and we can't solve for a. So that doesn't work because the y-intercept is actually 0. It's the point 0, 0. So that will not help because a will vanish because it's multiplied by 0 on the top. So then what do? Notice that we have a horizontal asymptote right here. Horizontal asymptote, y equals negative 1. They're giving us that. Remember that? Remember what that does? Remember that tells you the a just directly tells you the a is negative 1. Do you see that? That directly tells us the a is negative 1. How do we know? Because a horizontal asymptote is as x goes to infinity. So if you take this function y equals a and you multiply it out the top, you'd get, oh, and by the way, x minus 0 is just x, isn't it? So let's just make this x. Distribute. Because that was x minus 0. That was this point right here. X minus 0 is just x. That'd be x squared minus 2x. And then the bottom, if you multiply that out, you're going to get x squared minus 5x plus 4x minus 20. Remember, all that matters as x goes to infinity is the most powerful term, top and bottom. So y is a times x squared over x squared, which cancels. So y is just a. And where's y going? Negative 1. Y is negative 1, so a is negative 1. So there it is. There's our function. They just took this x on the top and they put it in the front. That doesn't matter. You could put it back on the top instead. It doesn't matter. To be in the top is to be in the front because anything in front is over 1. It's the same as being in the top, right? So there we go. There's the answer. Number 13. So same kind of thing on number 13 here. So y equals a. X-intercepts on the top, vertical asymptotes on the bottom. X-intercepts, what do we got for X-intercepts? Boom, right there. At 1, that's first power. Because it doesn't bounce, it passes through. So opposite, first power. On the bottom, we have negative 1, so that's x plus 1. It goes down on one side, up on the other, so that's first power. First power, and then this one 4, opposite minus 4 goes down on one side, up on the other. That's first power. It's right. It's only second power if it's like a bounce, if both are up or both are down. So now we just find a. How do we find a? Plug in. This time we do have a y-intercept. We don't have any horizontal asymptote to use, so we're just going to use the y-intercept 0, negative 2. Plug it in. Negative 2 for y, x for 0. And we get negative 1 over, what's that going to be, 1 times negative 4. That's positive 1/4, right? Because negative over negative there. And then how do you finish solving? Multiply by 4 over 1, boom. A is negative 8. There we go. There's our function. Easy now. Now, number 14, they want us to work backwards on number 14. So, okay, how are we going to do this? Well, we're looking at the function, let me write it here a little bigger, negative 4 times x minus 3 on the top, x plus 3, x minus 4 on the bottom. Okay, remember what we learned? That on the top, these are X-intercept points, right? Whatever makes the top 0 makes the whole fraction 0, makes y 0, so it's an X-intercept. And it's opposite, so x equals plus 3. The bottom, these are vertical asymptotes, opposite again, negative 3 plus 4. So, which of these has those characteristics? Well, a couple of them. You can see this one's at negative 3. This one's at negative 4, so no way. This one's at negative 3 and plus 4. This one's at negative 4, so no way. This one's at negative 3 and plus 4. So we have two options that are left. It's either it's either this one or it's this one. How do we know which one? Well, they have different intercept points, don't they? This one hits at negative 1, 0 minus 1. This one hits at positive 1, 0 plus 1. Which one's right? Well, you just try it out. Let me try 0, negative 1. And we're going to see if it makes this equation true. So put in the y of negative 1 and put in the x of 0. What do we get? And that's 3 times negative 4, negative 12. It's negative 4 times positive 1/4. All right, well, here, let's just do this. Make this easier. Put this over 1, multiply. Negative 3 times negative 4 is positive 12 over negative 12, right? 1 times negative 12. And that's true. Negative 1 is negative 1. It works. So this is our answer. This is the right graph. If you did the other one, if you did 0, 1, it wouldn't work. Only 0, negative 1 works. Makes it true. Makes the left side equal the right side, right? So the point 0, negative 1 must really be on the graph because it makes the equation true. When you plug in 0 for x, negative 1 for y, it makes the equation true. Whereas if you did 0, 1, it wouldn't make the equation true. I could prove it right over here real quick. If I plugged in 0, 1, if I plugged in 0 for x, 1 for y, 0, 1, it's not going to be true. The left side will not be the right side. So again, this is x, this is y. So plug in 1 for y. And now plug in 0 for x. I'm just going to save some time here. So that's going to be negative 4 times negative 3 over negative 12. Put it over 1, multiply. These multiply on the top. Negative times negative is positive 12 over negative 12. 1 equals negative 1, not true. So no to that one. So it's just this one. There we go. All right, so on this one, same kind of thing. We've done this a few times now. Y equals A. X-intercepts on the top, vertical asymptotes on the bottom. Okay, what are our X-intercepts? Looks like right here at 3. That's a first power because it passes through. Opposite, x minus 3, first power. On the bottom, vertical asymptotes, negative 1, so that's x plus 1. It goes up on one side, down on the other side. That's a first power. Right, because it's not like a bounce; they're going opposite directions. And at 4, it's also a first power because going up on one side, down on the other. It's not like a bounce. So now we just find A. How do we find A? They're giving us boom right here, 0, negative 1. That Y-intercept one. So plug in 0, negative 1. That's x and y. So plug in y, negative 1, 0 for x. And we get what? Negative 3 over 1 times negative 4. Bring it over here. We get, what's that? Negative over negative? positive 3/4. Now, how do we finish solving for a there? Multiply by the upside down 4/3 on both sides, cancels. A is 4/3 times -1, negative 4/3. Divide that in your calculator, negative 1.33333. There's a. So there's a times x minus 3 over x plus 1 times x minus 4. There we go. Number 16. Okay, so how do we do this one? Yeah, this is number 16, and it's another one of these multiple choice ones that wants to figure out the right graph. We're working backwards, kind of. So we have y equals negative x plus 3 times x minus 1 over x plus 2, x minus 3. We know the drill here. These are x-intercepts, opposites, so -3, +1. And these are vertical asymptotes, the opposite, -2, +3. So which ones have vertical asymptotes at -2 and +3? Well, this one's at -3. It's supposed to be +3, so he's already out. This one's at -2, looks good. +3 looks good. What are his x-intercepts? Does he have a -3 x-intercept? Yeah. -3 x-intercept and a +1 x-intercept. Yeah, so far so good. Let's go on and try the other side. So again, I'm going to go over here and I'm going to have to write the function for us again on this one. Because these are the other two options on the other side. Again, it's x plus 3, x minus 1 over x plus 2, x minus 3. And we're saying, okay, these are the x-intercepts, -3, +1. And these are the vertical asymptotes, -2, +3. So, okay, so -2, yeah. +3, looking good. X-intercepts at -3. Yeah, that's hitting at -3. And +1, yeah. That's looking good. How about this one down here? This is -3 for a vertical? No, it's supposed to be +3. No. So that one's out. So we have two options left. It's either this one or it's this one. How do we know which one? We got to check the intercept on this one. So how are we going to do that? Well, it's kind of hard to tell, isn't it? All we can see is this intercept looks like it's over 0 up a positive number. Looks like +1/2 maybe, right there. And this one, right here, that looks like it's over 0 down a negative number, right? It's down a little bit. It's below the axis. So over 0 down some amount. So I got to find out which one's right. So let me try. Let me try plugging in x0 and see if I get a negative number or a positive number. Yeah. So let's plug in x equals 0 and look at y equals positive or negative. So let's try it. So we got y equals negative. Going to plug in x is 0. So that would be 3, -1 over 2, -3. So what do we get? Negative, that would be -3 over -6. That's 3 negative signs, so that's -1/2. So it's negative. So it's not this one, it's not positive. It's negative. Y should be negative. Y is -1/2. Yeah, like this one, -1/2. That's our, whoop, sorry, I did the wrong one. It's this one right here. Same thing, right? That's 0 minus 1/2. It's that one. That's our right answer. Okay. So last one, number 17. Same kind of thing. Y equals A. On the top we have the x-intercepts. On the bottom we have the vertical asymptotes. So y equals a. So what are the x-intercepts? We have one here at 1. Now that's a bouncer, isn't it? Second power. So that's x minus 1 second power because it bounces there. Okay, then on the bottom we have -1, so that's +1, and that's going up on one side, down on the other. So that's first power, that's not like a bounce. And then x equals 2, so that'd be -2. And look at that one. That one's going to be a second power because see how both are going down? It's like a bounce. They both go down. Second power on that guy. Okay. Now we got to find a. How are we going to find a? We can plug in. Oh, there it is. There's the y-intercept. Plug in that y-intercept. X is 0, y is -0.3. So y is -0.3. X is 0. So let's see what we got here. Change the color here. So -1 squared over 1 times -2 squared. So what becomes of that? -0.3 is a times +1 over 1 times +4, +4. How do you solve that for a? You multiply both sides by the upside down. The reciprocal 4 over 1, cancel, cancel. A is 4 times -0.3 is your calculator, -1.2. There's the a. X minus 1 is squared on the top, just like we said. The x plus 1 first power on the bottom, x minus 2 squared in the bottom. There it is.